Cool. This is Loggers to Legends. It's a story of Mews and how we moved to open telemetry and the culture shift that we actually needed to get there. Oh, I'll have to duck a little bit. This is me. I'm Ben Wilson. I'm a senior platform engineer at Mews. This is my first talk ever. I've been coming to meetups for like 9 years now, and I feel like it's my turn to give back a little bit. So ask questions, because I always do, and I always feel bad when I ask hard ones, so please do. That doesn't qualify me to talk today, so what actually does? I was a teaching assistant. I've not really stopped teaching, and I've started mentoring recently. I love really deeply technical problems. This project was one of them. It was also quite a socio-technical problem, and we'll cover what that actually is about. Mews, I've pulled this from the FAQ. What's an operating system for hospitality? We're actually a SaaS provider, so things like cutting key cards, check-in, room inventory, things like that. Keeping in sync with like booking.com and all those kinds of sites. We're hiring, speak to Ben as well. They're also hiring people. I got told to give a fun prompt at the start, so I'm going to keep it hotel-based. When you check in, what's your receptionist when you hand over a credit card? If they write on a post-it note, yeah, probably get a new card. If they're typing it into a system and you get like a pre-auth, that's fine. It just probably means that they actually store your credit card on a file somewhere. It's not good. Mews, for about 2 years now, we've been improving. We adopted an incident platform, Instant.io, about 2 years ago. And soon after, we also adopted open telemetry. We saw costs creeping up over time, and it was a bit of a whack-a-mole, like trying to keep them down. Incident counts were going up, and we adopted a new platform. So at first, we were like, oh, is it actually because we've adopted a new platform, we're actually tracking it properly now? But actually, we started to realize that it wasn't the case. We were actually having more incidents. Bad observability. That's a qualitative one. We didn't, like, other than like customer reports being the main factor, we didn't really know like how good our observability was. So we wanted more internal reports, more observability actually triggering incidents rather than customers saying, hey, we got a problem. So our observability was a bit shit and we paid a lot of money for it. Let's actually talk money. Scumbag New Relic emoji was used quite a lot in our Slack. It is actually a really good product. Like, I'm not going to talk them down too much. It was really well rounded. They just cost a lot. So we're talking about $200 per seat. And these were tiered seats. So like, it was cheaper, but we actually wanted the high tier seats. It's just the useful bits were hidden behind $200. And if anyone actually does pricing on things, that's actually fairly steep. Competitors, all but one, were actually based on ingest cost alone. We evaluated CoralLogix, Honeycomb, Grafana, and Datadog. I did have a slide on vendor personas, and I'll keep it short because I'm skipping it, but there's two kind of vendor personas. You've got at-cost vendors. They're really cheap. You're just paying the ingest cost. And then you've got your premium ones. So like Datadog is actually kind of one of those. Your Splunk, things like that. So savings, who doesn't love savings? We don't actually have exact figures on how much we've saved because it's a little bit complicated, but it's between 500k and €1 million, which is a lot. We actually told like higher ups it was 750k, bang on in the middle. All the vendors, they were really competitive, and all of them were bringing about a 60 to 70% saving. We picked CoralLogix in the end. TLDR, if you want to save 500 grand to $1 million, just pick an at-cost vendor. So have a look whether you have a premium vendor, and if you're using a premium vendor, just switch. It's easy, exclamation mark there, but it's actually not that straightforward. So how did we actually do this? The easy bit was actually, and this slide is short, but this took the longest part of the project. there's two things that you need for mobility of your data. Adopt OpenTelemetry, that's my recommendation, and OpenTelemetry collectors. So we were lucky, New Relic, they supported OpenTelemetry. So they have their own vendor SDK. We used the OpenTelemetry SDK alongside the New Relic SDK, and we were able to send data from both. If you're unlucky and you don't have the option for OpenTelemetry, I don't really have any great advice for you. You might have to write some custom code to get that working. So before I mention collectors, what are they? They're an appliance that you put in between your code and where you want it to go. So it's kind of a proxy. So this was really essential during our migration. Stage one, we switched from sending direct to the vendor. So rather than sending direct to New Relic from our applications, we sent to the collectors. And then the collectors would buffer up the data and then send it to our vendor. Stage two, this was during the POC. We just added all the different vendors to the list of exporters. That's an OpenTelemetry term. And it just started sending. It worked. Ta-da, you're onboarded to these third parties. Stage three came a little bit later, like this was actually just a few weeks ago. Once we were happy with the migration, we just switched it off in the collector, so we stopped sending to New Relic. This was time consuming. The collectors, how many people use YAML every day? DevOps. We're all YAML engineers. It is straightforward in a sense. It's just, you'll never be confident with your changes. You'll make a change and then you'll let it burn in for a few days and then you'll be like, okay, that's fine. So it takes a while to actually migrate. OpenTelemetry. Have I said OTel yet? No. Cool. Right. I've done all right then. OTel is just another name for OpenTelemetry. It's a shame this slide boils down to not very much. OpenTelemetry is really cool. Like, there's a lot in the ecosystem. I'm just going to cover the headline of this. So OTLP, that's your transport/protocol. It's not special, like it's not like a custom protocol of any kind. It's just HTTP. You get two ports. You can either send on HTTP with JSON or HTTP with protobufs. And then the other one is gRPC. And if you know gRPC, it's still HTTP with protobufs, just a little fancier. It's an ecosystem. So this one's a little bit vague, but because everyone's kind of adopting this as a standard now, everyone's contributing to this ecosystem. Like, you're probably using a tool which supports OpenTelemetry at this point. Lots of open source and commercial stuff. Also, like, quite a wide amount of languages now are supported. And if you've got like a MS SQL, MySQL, Redis, whatever, all the libraries exist for these now. And this is my favorite bit, semantic attributes. This is where the magic happens. So before I said just put a collector there and you're mobile, but semantic attributes is actually kind of what makes your data mobile. It's a complex set of words, but I can boil semantic attributes down to a bunch of experts somehow managed to agree on something, so which is rare. If you like the XKCD comic, this probably will ring a bell. They've created a new standard, but it's not just a new one and some people adopt it. It's actually pretty widely adopted now. Like, all the major vendors are kind of using OpenTelemetry. And they've replaced the predecessors. That's quite important. So what is semantic attributes? The closest thing that I can describe them as is who uses like cloud providers, AWS, Azure. So you know what tags are, right? Cool. They're just tags. So they're an agreed upon set of tags and also agreed upon set of values. So on there you'll see we've got an example of HTTP request method. This just describes things like the different HTTP verbs. So you know that the method that was used to connect to your API endpoint might have been a get, post, or delete. So those are like a limited amount of enums, I guess. Then you've got ones like HTTP route, which are free form. So a HTTP route could be like /users/ and then a user ID. The only thing that these kind of free-form ones usually do is they kind of have restrictions in there. They say, okay, don't just send whatever you want. Who's written like an API server before? Cool, a few of you. So you'll know that if you've got variables in there, it's probably defining something like user ID in the path. So this is what this is for. The term is cardinality, and they want you to have low cardinality. All that means is keep your variations down. So when you go to a vendor, you've just started shipping to a new vendor, what they'll do is they'll have dashboards built in. So let's say HTTP again. There's 25 stable semantic attributes that you can use for HTTP, and the HTTP verb one and the path one are good because you'll immediately start saying, okay, I'm getting this many requests to this particular path. So they can build dashboards out of the box, which is really nice because you probably know if you are using a vendor SDK, it works with that vendor, but then it won't work with a different one. So it's kind of like a standardization of the ecosystem. Cool. Taking a bit of a tangent there. That's my favorite bit. I'm going to try keep it a bit more focused now. That will become relevant shortly, but I want to talk about misaligned costs. We had a bit of a game of whack-a-mole, I mentioned, and this is because our costs were growing and we were chasing product teams. We owned the costs. My director owned the costs, and he's like, Ben, how do we keep these costs down? And I'm like, we'll play whack-a-mole for a bit. And that was about a year, and then we decided, you know, we need to sort this out. Product teams were doing what they could. They were sending lots of login data. That's what actually compromised most of the cost. We did send some traces. We'll come on to this. We were sending a modest amount of metrics. But there was a bit of an elephant in the room for my team, and we were putting it off, and it's called the transactor. So we've got a monolith, and all the requests that come into the monolith and all the jobs that run, effectively the transactor is just kind of a wrapper function around all of those. And what we did, very smart thinking, is we decided to log anything that they returned from that. So we'd JSON serialize whatever they returned, and we'd log it. So we owned the log line, but we didn't own the data that we were logging. We had downstream consumers of this, so product security, data platform, and the product teams themselves. So we were struggling to actually mature on this part because we owned it, but we couldn't control what was happening, and other people needed it as well. Cool. We're going to go a bit faster now. These slides are a bit more my comfort zone. So it makes a bit of a presumption that you know what logging is. Hands up. Cool. Right, so this will be familiar. Hello world of two logs. So we've got two different languages here. They do the same thing. Language isn't really the subject. I'm going to stick to JavaScript because it fits on the screen a little bit easier. Anyone guilty of this? I'm doing a talk on about why you shouldn't log, and I write swear words all over the code if it's local, and then just to see whether something executed. It's a bit of a hammer to a nail, but it actually does work. Like, you don't really need to attach a debugger. I'm not saying don't stop doing this. Slightly better, we're now doing some structured logging. So we've got a domain. Not the slide I thought it was. We've chosen a key to put a message in. We're going to call this message. It's just JSON payload. We're going to pretend this log is in a domain called greeting. And we're going to add a target key called greeting, target even. And we've got two different logs. So hello world, hello Manchester. So you'll probably be familiar with log levels too. Some log levels, like error, they introduced their own semantics here as well, like an error key, just the word error, and it will actually have like a stat trace in that something. So your vendors know where to find the actual error message. You can start to add domain context into your logs. So we're creating a new user, and in this log we're adding a user ID. Now, you can start to also add system context. So this is things like databases, Redis, things like that. So in this example, we've added some time for how long it took to do a bunch of DB requests. In the transactor that I mentioned before, I did look this up. We've got 46 different attributes on ours for system context, which is a lot. And that's a lot of information to be storing. My director wasn't happy about this. So is all this stuff useful? Do we actually need it? If that scratched a little bit of an itch for you, then you'll like something called wide events. And I'll include a link at the end to what wide events are. But to summarize it, wide event is anything like logs, traces, which contain a lot of domain context, important domain. But there's a nuance to this. Domain, if you're not sure what that means, I'm going to describe it as a unit of work. So it's something is happening. And you might have something happening under that something happening. So in a request to create a user, you might do a DB request. So what's a unit of work? There's some really well-defined ones. Before I mentioned semantic attributes. And those are really good because these are already really well-defined domains, database, Redis, etc. If you own some shared code or a library, then you're probably going to start instrument. If you pick up open telemetry, I hope you do. You're probably going to start writing your own instrumentation for these. So in this example, we're creating a user. That's a unit of work. Let's pretend that's a HTTP endpoint. So we'll probably have, like what I mentioned before, a HTTP verb, the path, etc. All those are semantic attributes that we might add onto our wide event. We've got another unit of work. Does the user already exist? So we're doing a database call here. What's the database that you're calling? How long did it take? What flavor of database? MS SQL, Postgre. Another unit, the user already existed. So we're going to create an error. Is that normal behavior? So a login is someone logging in and then getting the password wrong. Is that an error? So these are the things that you should ask yourself when you're doing instrumentation. Another unit. So the user didn't exist. So we're going to actually insert them into the database. That's a unit of work. So again, what's the database? How long did it take? What's the flavor of database? After that, it's not really on the diagram, but let's say we then cache the user's profile into a Redis cache. So that's another unit of work. In most cases, you won't be writing these yourselves. Like this might sound like I'm just going, okay, do a bunch of work. But actually, there's a lot of instrumentation libraries out there. You don't actually have to do this yourself. You just npm install or NuGet install. Finally, we emit a success event. But what was actually successful here? So we're creating a user. Let's say we didn't actually define what the user ID was, and the database is the one that actually generates a user ID. What was the user ID? Let's add that into the event. So, scenario time. A customer has reported an issue with creating a new user. A ticket has come into the support team. This actually happens for us. So we now have established that a specific event, a wide event with semantic attributes for this particular API endpoint. The support team can just go, okay, I'm going to look up this particular endpoint, see whether there was any errors on it. And they can see maybe the database timed out. And we know what database it was, we know what the query was, etc. These arrows might be super convenient right now, but logs don't provide you arrows. So how do we correlate things? Correlation IDs, problem solved. So just shove a unique ID in there and somehow pass it through the system and log it in every single log that you've got. This is really good for filtering, but it doesn't really add those arrows in there. It just gives you a bunch of logs that you know are semi-related to each other. So it's not really hierarchical. We can do better. Modern system design requires modern solutions, but tracing isn't one of them. It's really old tech at this point. But the standards are new-ish. So I'm going to use the word span here. That's just those boxes that you see on the right-hand side. So each box on the new line is a span. And there's many spans to a trace. Tracing feels a bit like a log under the hood. It's just a bit of JSON. So if you're already doing structured logging, it should feel familiar. The attributes are kind of where the familiarity will be. So if you're adding bits of information in there, that's what attributes are. They're just tags in your logs. Tracing implicitly has durations, so that this slide here, the length of it is a duration. It's also got a timestamp, so when it starts versus when it ends. And it also has a name. It also includes eventing. So a lot of people like eventing. It's a bit of a macro detail. So let's say you're connecting to like a weather API. So you've got a website, you want to display the weather, you're going to connect to a weather API somewhere else. You're going to use a HTTP client, and you want to know whether this is working or not. An event could be useful for like a DNS lookup, for example. So you're connecting to the weather API, it's doing api.weather.com, and it tells you, okay, 50 milliseconds, the DNS was done. So that's what events are really useful for. It's like a finite timestamp, a bit like a log, on a span. There's a spec for the trace context propagation as well. So modern systems, how many microservices do you have? Anyone got more than 10? Cool. More than 30? Yeah. Cool. So microservices all speak to each other, and this is where you want to propagate. The correlation ID, if you're running it yourself, you could propagate via HTTP header. This is just a spec to say, here's how we expect you to propagate. And it supports different kinds of tracing as well. We have 3 services in that particular screenshot that are depicted by colors. Service name is how it defines it's gone into a new service or system. The W3C spec decides how we propagate that. So for HTTP, that's just headers, Kafka, headers, gRPC, baggage. It's a pretty generic standard that allows other people to implement it. So if you've got your own protocol, you can propagate it somehow. Wait a minute. I've tricked you. So we're trading logs here for something that for all intents and purposes is just more logs. And I'm telling you, add more data into that. That's going to cost more, right? Am I an industry plant? I'm not. Here's the magic. Tail sampling. So sampling is just a decision, like the word sampling just means yes or no. Do we keep it? Tail means at the end. So we're waiting to the end to make a decision on yes or no. In this example, we've got a browser in pink. We've got our monolith in orange. This isn't real, but our guest service in blue. And in this trace, an error happens. And I want to say, keep it. So that's what tail sampling allows you to do. It allows you to look at any point and go, okay, I want to make a decision on this. Does it have an error in it? Okay, it's got an error. Let's keep it. So long as the product teams instrument it that way. They've got to say, okay, an error happened here. And a lot of the instrumentation libraries, like if you're in a language which has exceptions and you've not caught an exception, you probably have a web server which will catch it. And these instrumentations can just hook into that and go, an error happened. Another part of tail sampling is probabilistic sampling. That just means we can say we want to keep a percentage of these traces. Why would you want to do that? Because you also want to see what good looks like. So you want to have a baseline of data, and then you might keep your errors so you can compare your errors to your baseline. So this is a decision somewhere, something's happened, let's make a decision on that. I was actually going to show you what our config looked like, but there's no point, I'll skip that. Transactor, it's time to address it. How do we reduce cost something that we own but don't actually really own? And people are actually at this point going, we really need that data. The technical bit of this is actually quite simple. So before I mentioned events, we moved our transactor logs to span events. So rather than just being a log, we just moved it inside the span. It's just a bit of JSON, like events are just more JSON, so we just shifted it. You can search for it like a log. So our users were happy about that. So for all intents and purposes, it's still a log. We actually didn't remove this log line. Before I mentioned we had dependencies on our product security, our data team, and the actual product teams themselves. We kept the product security and our data teams happy by still sending this data just not to our observability platform, because that's expensive. They had it in different systems entirely. But Ben, you said we're dropping a lot of data with tail sampling. In fact, we're going to drop 90% of this data. This pissed off a lot of people. So our product team, a lot of senior technical staff were actually quite unhappy with this. It was a bit of an awkward announcement to make. When people are telling you we actually need this data and you're going, sorry, you're not allowed that anymore. You need a bit of compassion, but you actually need to be firm with it. So this is one thing I would recommend. For that, I need a backup. So I had a bunch of people, I brought them together and said, I want to do this. This is going to save us 500 to $1 million. I didn't actually know at this point, but we knew it was going to save a lot of money, and they were behind it. And they backed me on this, and they were also pushing for this as well. There were some actual use cases where people needed the data, but kind of called the bluff on a lot of people, and they didn't actually need this. They just thought they needed it. And we offered alternatives to these people. So one thing I would really recommend is be human about it. Sit with people, have a talk. If you're in the office, have a coffee with them. People get a bit aggy on Slack. So yeah, talk to people. We did offer flexibility for people, but it came with a bit of a catch. So my director, because we owned the cost center for this, and it was a lot of money, he was pretty behind the idea of people owning the cost. So when people were like, no, we don't want to listen to this, we don't want to do this, we don't want tail sampling, we went, okay, that's fine, but you're gonna have to talk to your director, which sounds a bit mean. We were trying to be mean, but it is a bit of a back pressure to the system. So when people are too busy doing features and stuff like that, they forget that companies are there to actually make some money, and if you can save some money, brilliant. So we said, if you want to keep all your data, you've got to speak to your director and explain why you need to keep the data. And in a lot of cases, if it takes 3 days to do this and you're saving, like some teams, we could probably guess they were doing about 100K in logs. It's a lot of money, and it's a lot of money to say, I can't spend 3 days doing this. So it was just back pressure. They did it. They stopped complaining and actually went and did this stuff. We have quite good psychological safety at Mews, so we didn't feel too uncomfortable actually doing this. No one really wants to say money please to the director. I got a lot of credit for this. I did lead it, but there was an actual army behind all of this. Procurement consisted of 3 of us, and we enlisted a bunch of people to help do the testing. They were helping gather feedback in this group. And we had a lot of testers, and we turned those into observability champions. This might be one of the most successful things if you want to take this to your own org. Our observability champions were key to the culture change. They were eyes and ears, and in a lot of cases actually doing the implementation of changes. We had 30 plus of them across many product departments, and there was at least one person in every single team. We did an offsite with these, so we're based out of Prague, we're a global company, so we brought everyone together. That's a lot of money to actually invest. So we had backing on this. 30 people in one place. It was good beer, good food. We had a private channel for these champions. So if they didn't feel like they knew an answer, they could ask us, because there was a few of us who had really invested time into learning this. So the champions could focus on their product domains rather than the nitty-gritty detail. So they could ask us questions if they wanted. It was really good as well if they weren't sure on like how to name something, for example. We had one staff engineer, the CTO said, please get us a policy. This policy was like a North Star for people, so they knew what they were implementing towards. But if they didn't know what they were implementing towards, they could ask in this channel, and they did plenty of times. So we were able to kind of like build the policy as we went. We had a public channel. This was really good. If people just had generic questions, they could ask there. The champions would always jump in and help, which was really useful, because there was, at the most, it was 3 of us actually working on this. At worst, 1. So the CoreLogics, who we picked as a vendor, they have really good chat support. So if people just had usability issues, they didn't really know what they were doing, they'd just go to the chat support and they'd send them a documentation link and say, here's how you do it. They also had an academy, which was really nice. It was just a course that we sent people before they even had access, so they could go and upskill on how to use the platform. My colleague Ethan is actually organising an entire day of training for people, because it's no good just having these champions, because they will upskill other people, but you we're an org of 400 developers. 30 people can't train 400 people. So we need to kind of do a global thing. That's happening next week. So feel free to ask me how that goes. I'm not actually doing a talk for that. Cool. That's it. That's the reason I've gone grey over the last 8 months. Hopefully I've covered enough. If you are inspired to do this in your own organization, you can save a lot of money and do better. Resources. There's a really good post, loggingsucks.com. It kind of helped inspire this. Like, we were doing this as this website released. It's really interactive. I would recommend it. GitHub, really useful tool. Use the search. If you're doing collector config, you can find loads of great collector configs. And also the O'Reilly book by the Honeycomb folks, really good. Feel free to reach out to me on LinkedIn. We are hiring again, got a good dev blog. If you do have questions and you're not comfortable asking, I know there's a lot of people here, feel free to message me afterwards, I don't mind. Or just talk to me. Any questions, if we've got time? Cool. Ben?
Craig, can you read out the question?
Yeah. Cool.
So I've got one question with 2 parts to it, so apologies. The first is, how do you handle cardinality with semantic attributes that have 3 text fields? Because obviously if you have lots and lots and lots of different values, you may lose the value there. And the second one, which is probably more from my own curiosity, which is the Open Telemetry protocol. Does that allow you to enforce enums on those 3 text fields when you receive the data?
Okay, I'll answer the second one. The second one was, does OTLP allow you to do restrictions? No. So the collectors would be where you add kind of like filtering and stuff like that in there. The SDKs will implement, the integrations will implement certain semantic attributes, and those are constantly changing as well. If someone adds a new HTTP verb, which is actually kind of happening at the moment, they'll just add that new HTTP verb in there. But technically, no, nothing is stopping you from doing what you want. First question was, remind me again.
The first question was, how do you handle cardinality?
Okay. Yeah, cardinality is a tough one, and we still had the problem with New Relic. So cardinality just pressure people into not sending high cardinality data. So one example is we had a metric which was, and by all means, send high cardinality data for tracers. That's fine. It's just they've done some good developer experience there, like the low cardinality names and things like that are for a good developer experience, but you can still send a high cardinality data. Metrics, not so much the case. That's really expensive to do. That probably should be the main factor. Technically, it's also hard to do. Like, whoever the vendor is, it's a really technical problem to actually have high cardinality data. Just keep an eye on it. That's all I can say. So we had a metric which was tracking jobs, and they had unique job IDs. And one day someone decided to add those unique job IDs as a dimension on these metrics, and it started costing us a lot. If you say that, people usually stop, but nothing stops people from doing it, and that's why it's really tough. Dimensions is just a mathematical, cardinality is just a mathematical problem, so the more dimensions you add, the more cardinality you're adding, the more cost it is. So if you've got something which is like a unique ID for a user, probably don't put that in a metric. But you can keep it generic and then have traces, for example, or logs, which have the high cardinality data in, and that's how you kind of drill down into a problem.
Thank you.
No worries. Cool.
You kind of answered it because you said you weren't sure, but I was going to say, have you seen the Open Telemetry Weaver, which Okay, so you can specify policies through YAML,
Cool.
which allows you to define your own semantic attributes. And so if people are reusing, say, a public attribute like http.method or something,
Yep.
it will flag up a warning saying you're using a pre-used one. Likewise, you can define your own one. So if you use user ID as the name, but
Yeah.
someone else uses customer ID,
Yeah.
it says, right, you're starting to diverge, so have a look at that.
That's cool. I'll have a look at that. That was
Weaver.
Weaver. So that is a way to enforce your own semantic attributes.
Yeah.
Cool. Any other questions?
So you've picked an at-cost vendor.
Yeah.
Thinking about the life cycle of that company, presumably that's not their plan forever. So how much of your infrastructure is, so the instrumentation, I can understand that being open telemetry and that's
Yeah.
all kind of fixed and it's going to stay as standard. Is it the collectors where you've got the kind of vendor-specific stuff?
A little bit.
Yeah.
So the question was, at-cost vendors, is there a risk to staying with an at-cost vendor? And if so, how can you mitigate that risk? Yes, so there are some vendor-specific stuff in the collector. They open source a lot of their config. Like I said, GitHub search is brilliant for this. In fact, I discovered like new spec things by just going through the GitHub search. There's a lot of cool things in OpenTelemetry. So yeah, we kind of de-risk a little bit by putting some of that into the collector. We would rather not have that in code. But there's not a lot of that. An example with Coralogics is they're trying to do nothing to do with our transactor. They're trying to do a transaction, and they've implemented their own spec for how to do transactions. They have their own processor for that. You could use that. Technically, you could migrate to a different vendor, but they would have to support that extension of the spec. But yeah, there's not a whole lot of vendor-specific stuff in it, but it does exist. Cool.
Anyone else?